It went away?
Yeah.
Again, overloaded operators. This next lab, or this next section, is broken up into about 4 different things. 2 primarily though, one being overloaded operators and the other being virtual functions and polymorphism. So we're going to cover virtual functions today, and then we will cover polymorphism on Wednesday, and then graphics on Friday. At least that's my plan. So they're not entirely related. I just didn't want to break it all up into separate labs and stuff. So here we go. An overloaded operator. In C++, we have different operators that do different things, and what they do is based on the context. So if I say that int num equals 5 plus 4 plus 4, that's going to do something, right? That's going to add 2 integers together and store them in a variable. So that's one thing we can do with plus. We can also do multiplication. That's an operator. But what if we put the asterisk over here? That's totally different. That's a pointer. And then later on, if we wanted to, we could dereference that pointer using the asterisk. And it does something totally different in that context. And in C++, you can decide what you want your operators to do. Alright, and when you change the default behavior of an operator, that is called operator overloading, or overloading that operator. So that's what we're going to look at today. Another example would be if we had 2 strings. We can add 2 strings together. Right? And this behavior of the plus operator is different than it was. Before we were doing numerical calculations, now we are just concatenating 2 strings together. Right? It attaches the word dog to the end of cat. So the plus operator has been overloaded for the string class. Does everyone get the idea of what overloading an operator is? We define the behavior of the operator. Alright. I'm going to do 2 different examples. One is kind of silly. We're actually going to create a cat dog from a cat and a dog. The other is going to be a little more practical but kind of boring, so we'll get there. To start off, let's create a class for the cat. No, the dog. And the dog will just have a name and a weight. We'll give the dog a constructor. No. Rover. And a destructor. We could put some cout statements in here, just so we know our constructors and destructors are working. We can also do a copy constructor. I'm going to come back to this later on. But since we're writing the constructors, let's go ahead and make a copy constructor. What else do we need? That's pretty good for now. All right, let's copy this class. Do Control C, drop down, do Control V. And then select the second class here. And hold down Control, Shift, and push H. So we're going to find all instances of dog, replace all instances of dog with cat, and don't do current document, do selection. And replace all. And then you can change the name to like a good cat name. Sure. And the dog, or the cat probably weighs a little bit less. Alright, down in main, we'll create the cat dog. We can close out the find and replace thing. Alright, we need a cat, so we'll create the cat. And we need a dog. Oh, I forgot to make everything public. 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 And now we would like to say what? We need a cat dog equals cat plus dog. Okay, that's all kinds of wrong. We don't even have a cat dog class yet, so let's go up here and make one of those. The top class, cat dog. String name and float weight. We don't have to do all that other stuff. Go ahead and make everything public though. We would like to do this. We'd like to put the cat and the dog together to create the cat dog. But what does that mean? It's flagging the plus sign because we have not defined what it means to add a cat and a dog together. Those are two different objects. So here's where the overloaded operator comes in. We're going to go to the class whose object is on the left. Cat's on the left. We're going to go to the cat class. All right. And we are going to basically, overloaded operators are like functions. They do some operation and they return the result of that operation. So, if this was a function, what would we be returning? What? No? What? What are we returning? If you're going to do this operation in a function, what would you return? Cat dog object. Did you cheat? Okay. I don't know. You might have cheated. Cat dog will be returned. Then you type the keyword operator, tell it what operator you want to overload, and we put parentheses here just like a function. What's being passed in?
A cat and a dog?
No. Just the dog. Right? Because we're already in the cat class. It's almost like saying cat dot plus and then passing in the dog. So, in goes the dog. And then we give the operator a body, just like a function has a body. All right, inside the function, we'll create a cat dog. And we'll do some stuff that we think needs to happen when a cat and a dog are actually added together. We will say the name, let's see, cat dog dot name is equal to, let's just say cat dog space plus the name of the cat and the name of the dog. And we could define the weight. As, let's say it's the weight of the cat plus the weight of the dog divided by 2. Kind of take an average, right? That makes more sense than just adding them together. And one last thing, if we're going to return something, we need a return statement. So return cat dog. All right, let's see if this works. It's happy with this now because we have overloaded that operator. And let's do a cout statement. See if it works. Okay, our CL statements are mixed up with all our constructors and stuff, but it does work. Wait, no it didn't. We're missing something. What's missing?
Dog's name.
The dog's name. Up here I see a dog got copied at some point. I provided my own copy constructor. By default, there is a copy constructor, just like there's a default normal constructor. But if I do overload this thing or override it, provide my own, however you want to think of it, I have to provide everything that a copy constructor would do. For right now, let's just comment that out so that the default one will be used. Run it again. There. Cat, dog, Greg, Rover. It's good. And the weight is somewhere between the 2 and the 4, as we expected. Everyone gets it? What's weird?
I got 3.15. You got 3.6. Well, that means do wrong. Okay.
Yeah, that's exactly what that means. Do you have this number correct?
Oh, you put it. Do that. I said too wrong.
Yeah,
Makes sense.
I was being
Savage, you're not counting the right poundage for your animals.
Okay. So there's that. Questions? Easy enough? Let's overload another one.
So with that though, you couldn't do cat dog, equals dog equals cat unless you go through the
Right.
build it for dog.
I don't know, we could try it, but I don't think that would work. That doesn't make any sense. Everyone knows that a dog plus a cat is a dog cat, which is not a real thing. So this does not work.
Sorry for my.
Right. Now, you could probably try a whale shark and that would work. That's a real thing.
The non-shark one?
No. Not a real thing. We're gonna go ahead and, whoops. Let's bring back the copy constructor and provide the guts for this thing so it actually does what it's supposed to. The default copy constructor does a bit-by-bit copy. It goes and looks at the object that it's copying, and it just reads in those numbers bit by bit, and it writes the same exact values over in the one that's being copied. Okay? Let's just look at that for a second. So if I have a dog here, and I want to create another dog, I can say dog, dog2 equals dog. Alright, now they have the exact same name and the exact same weight. It looks at the first dog, it takes whatever values are in here, and it copies them over. And if I changed anything in the dog, in the original dog, then it would copy that over. I'm going to put cat dog on hold. So if we do C out, dog2, dot name, what should you see?
Fido.
Should see Fido. works just fine. Something closely related to the copy constructor is the assignment operator. What if I create the dog on this line and then down here I say dog2 equals dog? Is that effectively the same thing? Does it work? It works. But we're not using the copy constructor because we're not constructing anything, we're just copying it. So it's using the assignment operator. That has a default operation, it's a bit by bit assignment. Almost exactly the same, but it can be important to overload the assignment operator. Let's go up here and let's create a structure for collar. Right? Sometimes dogs have collars, and we'll just give it a length. And let's say in the class, we want the dog to have a collar, and for some reason it needs to be dynamically allocated. So we'll give it a pointer, and then in our constructor we will just say collar equals new collar. So now even if my dog is created on the stack, the collar is on the heap. Now, with the bit by bit copy in mind, what happens right here with the collar? Two dogs sharing the same collar.
Sounds very restrictive.
This is wrong. All right, we can't have that. You can see how this could be very problematic.
Especially for the dogs.
All right, yeah, you can't have that. So
Or it's a big collar.
let's fix that. If, pay attention, I'll probably put this on the test. If you dynamically allocate memory in the constructor of a class, you need to do three things. One, you need to clean it up in the destructor, and this is probably the most important. Number two, you need to override the copy constructor. Why? So if the dog gets copied, it has its own collar. And you need to overload the assignment operator. So in case one dog is assigned to a different variable, that dog will have its own collar. So let's do that. Overloaded operators. What are we returning? Dog. Operator plus, no, equals. And we're passing in a dog. You can usually just copy the stuff in the copy constructor and paste it down in there, or you can do it like we did earlier. Just create a dog here, and just manually type out everything. New collar, not a copy of the other collar. I don't think we need that. We probably could have just used this. Anyways, now both dogs will have their own color in either case. That should be fine. So if you dynamically allocate memory in the constructor, you need to deallocate in the destructor, you need to provide your own copy constructor, and you need to overload the assignment operator. Right there. In most cases. Now there may be a case where you've got several objects sharing the same texture and you really don't want to recreate that texture every time. Maybe it's okay if they all share the same texture, that would be okay. Just be aware of what's going on there. In some cases this is not okay, and you need to go ahead and allocate that new memory. And you may think, well, I'm never using this in my program. I'm never assigning one object to another. But you may be using other libraries, especially in the STD library where we've got vectors and vectors and decks and queues and stacks and maps and sets and a bunch of other cool things that make life easier. You don't really know what's going on in there. And you load those up with objects, it may decide to use those operators, and you know that could cause problems if you haven't taken care of this memory allocation stuff. All right, any questions?
I have a question.
What?
I notice sometimes when you do like d.collar equals new collar, you'll put a parentheses after the last collar.
You should.
Does that matter?
I don't think so. Like in the book, he doesn't always do it either.
Yeah.
But as long as you're not invoking a certain number of argument constructor, then it's probably fine just to leave it without. It doesn't, I don't think it matters. Should do the same thing. All right, so there's our silly example. Let's take 5 and then we'll look at a more practical application. So for vector, all right, normally with 2D vector, you're just going to have a float, x and y. And then if we want to overload the operator for a vector, how does this work? Let's just do plus. We want to add 2 vectors together. We're going to return a vector. And we're going to pass in a vector. I didn't create a new one. I decided to use this one I'm passing in because I passed it in by value anyways. So I think I can get away with that. I don't know, we'll try it. Create 3 vectors down in main and we'll give them, we'll set up A and B. A dot x equals 10 and let's write a display function. That will show the x and y for any given vector. We'll call c.display. Does it work? Totally works. Good job, guys.